Hello friends, welcome to Engineering Funda family. In this video, I'll explain you antenna apertures with great clarity. First of all, you need to understand what is antenna aperture. See, antenna aperture is nothing but it is area of antenna, or you can say it is region of antenna. Job of antenna is to capture electromagnetic waves. Those electromagnetic waves are captured on some area, right? So antenna aperture explains you how antenna captures electromagnetic waves, right? So with different antennas, different equivalent areas are there that describes power capturing characteristics of antenna. Those different equivalent areas can be classified as per physical aperture, collecting aperture, effective aperture, scattering aperture, and loss aperture. Here I'll explain you all categories of aperture with great clarity. Let us start this video with first category, that is physical aperture. To understand physical aperture, I'll be considering horn antenna example, where you can observe here we have horn antenna, and this horn antenna is having opening over here, and this is rectangular horn antenna. So it is having opening dimensions as per A into B. So physical aperture, that is physical dimension of antenna which will be receiving EM waves. So physical dimensions are how much? A into B, right? So physical aperture is A into B. So this is what the aperture which is responsible for reception of EM wave over here with this antenna, right? So physical aperture explains physical area of antenna to capture EM waves. It depends on physical structure of antenna. With horn antenna, you can clearly understand that as per this opening, where with this opening only, this horn will be receiving EM waves, right? So physical aperture is A into B as per these dimensions, right? Now, based on physical aperture, ideally, how much power should be received by antenna? So ideally, power received by antenna will be based on average power density. Here, as if average power density is W average, then average power density into area, that is physical area, that will be ideal received power by this antenna, right? So physical aperture explains you physical dimensions. Like ideally, these are the areas where antenna will be receiving electromagnetic waves, right? But this is ideal calculation with respect to physical aperture. Now I'll explain you second category, that is collecting aperture. Here you need to understand difference in between collecting aperture and physical aperture first. See, collecting aperture of an antenna refers to the effective area that is available for receiving EM waves. So, but obviously effective area is this much only, right? But in this, we are not only talking about physical size, but we also factors some antennas parameters like gain pattern, efficiency, and any additional elements that might affect its ability to gather incoming signal. So collecting aperture, that is not only depending on physical parameters, it is also depending on antenna's other parameters like gain pattern, efficiency, or any other additional elements which may affect its ability to gather incoming signals. So you can say collective aperture accounts for directional sensitivity of antenna. So here in collecting aperture, we talk about directional sensitivity of antenna. See, physical aperture explains you physical dimensions only, while collecting aperture explains you directional sensitivity of antenna, means from which direction how much signal can be received by this antenna, that can be described by collecting aperture, right? So here only one difference that is there in between physical aperture and collecting aperture. Physical aperture explains you what is the physical dimension where we receive EM waves, while collecting aperture explains you with this physical dimension how much sensitivity is there with respect to different direction. Like as if I say maximum directivity is there in this direction, then maximum EM waves that will be received from this direction. But here, if I say in this direction, directivity is less, then in this direction, less EM waves will be received, right? that is been described by collecting aperture, right? Now I'll explain you third category, that is effective aperture. See, we have talked about physical aperture. Physical aperture explains you ideal calculation of how much power is received by antenna. But effective aperture explains you how much real power that is been received by antenna. The reason is, with antenna, there can be different reasons for loss of signal, like horn is not uniform at opening. As if horn is not uniform at opening, then there may be a loss of signal over here, right? Second reason with horn can be the electric field at wall of horn must be zero, but practically not. So here we have walls of horn. As if on walls electric field is not zero, in that case there can be loss of signal. See, with this horn there may be tapering loss or there may be conduction loss, as these walls are there as per metallic walls, right? So with horn antenna we can have different reasons because of which we may receive less power compared to the ideal calculation. So here we need to understand aperture efficiency. Based on that, one can calculate effective aperture. So see, aperture efficiency is effective aperture divided by physical aperture, right? So effective aperture explains you how much practical power that we receive, right? Physical aperture explains you how much ideal power that can be received. Collecting aperture explains how much power is received from which direction, right? Now I'll explain you next category, that is scattering aperture. See, in scattering aperture, we need to understand how electromagnetic waves are getting scattered. In majority of cases, you will be observing from the edges and from the border, there is a possibility of scattering of waves. Like you can observe here we have edges, right? So at the edges, we may have scattering of EM waves, as well as from the borders even, one can have scattering of electromagnetic waves. So the area belongs to edges and border, that is there with scattering aperture, right? And last category is there based on loss aperture. See, loss aperture explains you loss of EM waves, and loss of EM waves happens in many sections of antenna. First one is there due to tapering loss, as if smoothness of this surface is not there, then also there may be loss of signal. Second loss is because of conduction loss. See, these walls are there as per metallic walls, so because of which there may be a loss. See, in conduction loss, usually what happens, like with walls, if electric field is not zero, in that case, it will be absorbing EM waves which are coming on the wall, right? So ideally there should be zero electric field on the walls, right? And if it is not there, in that case, there can be conduction loss, as we are using metallic walls over here with horn. See, there can be dielectric loss. In many antennas, we use dielectric material, and dielectric material is having loss tangent which absorbs electromagnetic waves, right? So because of loss tangent of dielectric material, there can be dielectric loss with any antenna, as well as there can be scattering loss. As I have explained, with different areas, we may have scattering loss like on the edges or on the borders of antenna. So on the edges or on the border of antenna, there is always possibility of scattering of electromagnetic waves, because of which there may be loss. So loss aperture explains you what are the sections in which there may be a loss of EM waves, right? While scattering explains you the areas at which there is a possibility of scattering of electromagnetic waves. So that is how different areas are there, which explains you how signal is received by antenna and how there may be a loss of signal with antenna. I hope you have understood this session. Still, if anything that you would like to share, please note it down in comment section. I'll be happy to help you. Thank you so much for watching this video.